Okay, we have to start this part. Compound Y, the molecular formula C5H10O2 reacts with sodium carbonate to evolve bubbles of a gas. It means that this compound have a carboxylic acid functional group in it, because only out of all the organic functional groups, the carboxylic acid is the one which reacts with this sodium carbonate. Okay. The proton NMR spectrum of compound Y in D2O is shown. Okay. So if you recall, if we have used D2O, then it means that the peak of proton of COOH, which means this proton, does not appear. Is this part is understandable to everyone?
Yes, sir.
Okay. Now we have a rest of the peaks over here, and we know there are 5 carbons and 10 hydrogens and 2 oxygen. And from this, what I could know that in the whole molecule, we have this structure, and this hydrogen is not appearing in the spectrum. Is this point is clear?
Yes, sir.
Okay. Now, it means here in the spectrum, the signals that are shown are for 9 protons only. Is this clear? What they are saying, use this information to suggest the structure of Y. Now have a look over here. If I look at this signal, as this signal is a doublet, right? Which means that the adjacent carbon have 1 proton only, and this signal is also a doublet, which means adjacent carbon have 1 proton only. Is this understandable to everyone?
Yes.
Okay. Now, if you see this signal, can I call it a multiplet? But if you count the number of peaks in this signal, there are 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. There are 7 peaks, which means that adjacent carbon have 6 protons. Is this clear? Yes. Is it clear or not?
Yes, sir.
Yes, sir, clear है.
2, 3, 4, 5, 6, 7. Okay. So from this, I can conclude that there is a possibility of this structure being present in the molecule, right? Now, if you see over here, this hydrogen showing this signal because on its neighbor we have a 6 hydrogen, and these 6 hydrogens are showing this signal because it's a doublet, and in their adjacent carbon there is a 1 hydrogen. So if you see, out of these 9 hydrogens, how many hydrogens we have figured it out? 6 and 7. So 7 hydrogens are figured it out, and we are left with the 2 hydrogens. So it means that this signal is actually of a D to it, and this CH is actually the same CH that is over here. So we got 3 different fragments in which we have a one common fragment, that is this CH, which is over here and over here. So it would help me to identify the structure. Now, if I connect these fragments, it can be a CH3 bonded to a carbon, and that carbon have another CH3, a hydrogen, and that carbon is further bonded to a CH2, and this CH2 is bonded to a carboxylic acid carbon, and that's why it is de-shielded. That's why it is actually appearing at the higher chemical shift. So this is the structure of Y. Is this clear to everyone? Now, what they are saying, use the data booklet, the proton NMR spectrum, and your answer to C1 to complete the table. Okay. So see, we have a first chemical shift at 0.95, right? And if you see over here, we have an alkene, and it's could be a CH3, CH2, or CH. And its signal is from 0.9 to 0.7. So it indicates that this chemical shift at 0.9 would be of these hydrogens. And as in the spectrum mentioned, we can write it, it's an alkane. So I can write either alkane, and I have figured it out. These are the CH3 group. So I can write it or CH3 groups. And if we look at the splitting pattern over here, these are this one, which are at 0.95, and their splitting pattern is a doublet. So here I would like to write doublet, and then they are asking the number of hydrogen atoms responsible for the peak. So if you see 3 hydrogens over here and 3 hydrogens over here, make it 6. So 6 hydrogens are basically responsible for this peak. Is it understandable to everyone?
Sir, why would we write 6?
Because see how many hydrogens here we have which are showing this peak.
We have 6 here, but only one of them will show the peak, right? Only one of the alkene molecules.
No, these all are showing this peak. That's why its magnitude is so big than the rest of the one. This the that are 6 hydrogens, and that is only one. Is it clear?
Sorry, your voice completely cut out. Can you say again?
Yes. The magnitude of the peak actually help us to identify the number of hydrogens. See, there are 6 hydrogens, and that's why the peak at 0.95 have a very big magnitude. That's why we can consider them that these are the 6 hydrogens which are showing this peak. Is it clear now, Ahmed?
Yes, sir.
And this peak is very small, so it can be a 1 hydrogen, and this peak is a bigger, so it means there are 2 hydrogens over here, which are these one.
So we did use relative to the size of the peak.
Yeah.
Okay.
Which help us to identify the number of hydrogens. Now, the next signal is 1.9. It is, if you see, this hydrogen is relatively de-shielded than the CH3 hydrogen. So that's why its peak is appearing at 1.90. So it is also an alkane because in its neighbor there are only alkyl groups. And it is a CH, right? If you look at its splitting pattern at 1.9, we have decided it's a multiplet. So I would write over here a multiplet. And then the number of hydrogens responsible for this peak would be 1 only. Is it clear now? Now, the chemical shift at 2.02. So we are only these hydrogens left, and these are next to carbonyl, which means they are relatively more de-shielded. That's why they are appearing at a greater chemical shift. So see over here, if you see alkyl next to carbonyl, could be these or this. In our case, it is this one. That C double bond O have a CH2 group neighbor to it, and its peak would be appearing at 2.2 to 3.0. So see, this peak is appearing at 2.2. So I can write over here the environment that there is an alkyl which is next to C double bond O or I can show it like this, that a CH2 bonded to C double bond O carbon. And when we talk about its splitting pattern, see, this is 2.20, and we have decided its splitting pattern is doublet. Now I think there is no need of this table. So I may write it's a doublet, and the hydrogens which are responsible for this peak are 2. So I can write 2 over here. Is this clear? Yes. If anybody have any doubt or any question, do ask.
Sir, which carbon has like 2 hydrogens next on it?
See this one. Let me highlight. It is showing a peak at 2.20. This one are showing a peak at 1.90. And these are showing the peak at 0.95.
Right.
Okay. So here we have ended the paper.